Thank you, and thank you, Finch, for setting the table for a very rich conversation that we're going to have today. I am Millie Corrigan, Vice President of Federal Civilian Solutions at Noblis, and I'm pleased to be your moderator for this morning's panel. As you look all around us, it's easy to see that we're only merely beginning to see the impact of autonomy on our world as we know it. And today you're going to hear from key government leaders as well as academic leaders who are really working on the front lines of this critical transformation, whether that's in vehicle automation, autonomous mobility, or whether that's working on the critical data and infrastructure and communications, as Finch mentioned, is so critical to acceleration, or technological advancements in AI, robotics, and computer vision. So without further ado, I'd like for each panelist to introduce themselves briefly, and then we'll get the conversation started. Yeah, go ahead.
Hi, I'm Josh Gustin. I'm our Manager of Communications, Information, and Network Programs, as was announced. So what is that? That includes all of the communications that we do at the FAA, the infrastructure, if you think of it as our network backbone for across the US, even into our international boundaries, that make everything communicate, includes satellite up in Alaska, microwaves on the West Coast, a lot in the mountains, network stuff that we all know and love with wires coming across the US. That's all included in the portfolio. Amidst that, also all the radios that communicate with the airplanes, that make the controllers talk to the pilots, all in that portfolio, 60,000 of them across the US. And information, among other things. So I have the SWIM program, System-Wide Information Management, which I've been a part of since inception almost a decade ago. That's really about sharing data with airlines and now sharing data with the world that we do outside of the FAA, everything that we share through the Open Data Act that goes out to you all. So, thank you.
I'm Jana Košecká. I'm a professor of computer science at George Mason University. I had the robotics and robot perception group there. I've worked in the field for about 20 years. I have sort of had some significant stays in the industry, collaborating on sort of various autonomous driving transportation systems, or in general robotic systems, with some of the industry partners.
Well, I'm Ken Leonard. I'm the director of DOT's Intelligent Transportation Systems Joint Program Office. Finch talked about the innovation portfolio at DOT, and we don't have the entire innovation portfolio in intelligent transportation systems, but it really is a multimodal look at what are really all the cutting edge technologies: connected vehicles, automated vehicles, artificial intelligence, cybersecurity, technology to help the underserved, and other emerging technologies in the intelligent transportation system space. And if you look at our almost 30-year history and the way Congress has defined that legislatively, it's a pretty broad portfolio.
Great, thank you, Ken. And given the unique set of perspectives on the panel today, I thought we'd kick off by having each of you describe where you see the current state of autonomy going as it relates to your mission set or your research objectives.
I'll let you go first this time.
Should I go?
Yeah.
Okay. So I feel, we are in exciting times. I think when it comes to autonomy, the roots of the field are very deep, and it has a very long history. All the components of autonomous systems, whether it's control, planning, or decision making, have a very long history in AI. And what is happening currently with these new advances in machine learning and data-driven techniques, there are these new synergies between the two fields, and it's really kind of generating a lot of new ideas, and sort of people are revisiting even the basic architectures, how this system should be designed. And so this is sort of very exciting. I think we'll be able to have tools and techniques to develop more robust, better performance systems. But the remaining questions still are, how to be able to guarantee the safety and some of the theoretical guarantees, but some of the traditional techniques sort of were better equipped to do so. So there is this kind of, I guess, joining of these different fields, and people are trying to figure out how to sort of make the best headway to develop these advancements in autonomous systems.
Great, thank you. Ken?
Yeah, I'll pick up on that. I talked about what we have in the ITS portfolio, and to me, autonomy brings and combines a lot of those. You can't talk about self-driving cars or autonomous vehicles or automated vehicles without talking about artificial intelligence and machine learning, without addressing that there are cybersecurity issues. And so it is this incredibly broad field, but a lot of it really starts right now for us with making sure the vehicles can actually perform at a level that we need to see them operate on the roadways. And at the same time we're doing that making sure we're addressing how do we test and understand how artificial intelligence is going to work in more complex vehicles and software systems. How do we ensure that the traffic system is immune from or resilient to cybersecurity attacks? And how do we make sure that automated vehicles can deal with that? And then of course there's the whole aspect of connectivity, and I know we're going to see a little demonstration later here that talks about the role of connectivity in the transportation system. And I tend to focus largely on the surface side, but we do work with FAA as well, which has a whole other set of issues.
Yeah. Well, we do have a surface too, right?
True.
So we include all that. I'm a bit of an infrastructure guy. You heard from my description. I'm also a bit of a techie, and I love the innovative things that are going on in the world. And if you look, I mean, my take is ideas are growing exponentially. I mean, we would not have been talking about this level of conversation 5 years ago, 10 years ago, right? And I attribute that to building blocks that have come along, that show up, that we take advantage of. One of those is connectivity that Ken mentioned, right? So that's where I live and breathe, and I worry about, especially in aviation, in safety critical environments, cellular and wireless, even satellite. They're still iffy for us. They're not guaranteed. We put in 2 paths to everything for safety critical systems to make sure we have diversity to handle that. But when you're generating ideas, you don't worry about that. You just start using what you have, and a lot of what we see, at least what I see in autonomous systems, you know, they're an ecosystem of systems that tie to other ecosystems, right? That's the whole general idea. They depend on that connectivity to work. They assume it. They're not going to build it. So what we're talking about here, and things here in DC where we have the luxury of that connectivity, you might not find in Kansas or Alaska or on the top of the mountain that I worry about where I need systems. And they may not also have the business presence to solve that. I don't know who's going to solve that. So our ideas are moving fast. I worry about that lower layer just being right to support the ideas. That said, again, these innovations happening so fast, these building blocks coming up so fast, once we need it, it gets solved. That's really cool that somebody takes that on, even though it might not be somebody in this room that's planning for it. The need just develops and that building block gets built. And I think we're all a part of different building blocks that come together. Again, the surface that you talked about, when you say it, I think of the surface of an airport. It's still vehicles, right? Same thing, how's that gonna work? So bringing all that together, I think there's still challenges at the infrastructure layer, but I think they're also being overcome as this stuff is developed, and I love seeing that every day.
Well, connectivity, integration, interoperability, that certainly cuts across all aspects of autonomy. And I think some of the challenges we're hearing this morning as it relates to user trust, hearkening back to Amer's opening brief, and how critical it is to achieve that trust in order to achieve greater levels of autonomy. Talking about some of the challenges in a safety critical environment, applying test and evaluation approaches to systems that have emergent and adaptive behavior that's unpredictable. Can we hear a little bit further on some of the additional challenges that you think need to be overcome so that we can achieve greater levels of trust and autonomy? Open it up to the panel.
I think I just did, so
all right.
Yeah.
I'll keep going. But you can.
Well, I guess, I think it's probably, so I'm not familiar to what extent sort of the government is actually engaged with industrial partners when it comes to this, right? So every company has their own set of tools and techniques how to go about evaluating the robustness and safety of these systems. And I think it's really critical to have this discussion and be engaged, and also enable the industry and companies to better communicate as opposed to compete with respect to each other. Because at the end, there have to be some regulation in place which will work for everybody. And I think this field particular, especially when it comes to data and testing and simulations, can tremendously benefit from some benchmarks and evaluations which will apply to all.
Yeah, I love that, if I may, Ken. Just come off of that, again, I'm all about the data in the FAA, and again, that's that innovation space. And I can tell you that having been there 20, 25 years ago, when the airlines were very hesitant to share data, they shared with us, with the government, but not with each other. And until they started sharing with each other is really where they got the best economic benefit. So I worry about it in this space as, you know, one company might be thinking, I can take that whole market. So the less data I give out, the better it is for me on a business side. That stifles innovation. And it's not necessarily the people in your room that come up with the idea, it's the people that build on that in the next room. Even to the point of, again, with automated vehicles, right? Likely not all one company. They have to be able to interoperate. Again, that's another challenge space that, again, in the FAA with our SWIM program, we've standardized all of our systems, spit out data the same way so we can give it to you the same way. It's not that it's unsolvable. You can solve it all kinds of different ways, but it just exponentially moves the ball forward quicker if you're not worrying about that infrastructure stuff coming back to that. So similarly in this environment, I would hope that we're working on, at a minimum, data sharing requirements, data sharing standards, just to say how to do it even in a minimal way. You know, as you said, through committees with you all that are doing it, to come up with how do you want to do it that protects your business but also opens up the innovation.
Yeah, I absolutely agree. And you touched on something, it's a little off the cybersecurity question, but data is actually essential to the cybersecurity question, because that is in part what we're trying to protect with cybersecurity protections, is the data that's in the system and the communication. Yep. So, you know, we have a program that we established in our strategic plan around data. It's one of our key focus areas. And we've started to look at secure data exchanges, because we recognize that automated vehicles are going to need a tremendous amount of data, and they're going to have to integrate tremendous amounts of data, and they're going to have to know that they can trust that information. And you raised an interesting point when you talk about competitive advantage in the private sector versus the public good and the industry good. And you look at what aviation has achieved with programs like ASIAS, where they share data that is at the root cause of a crash or an incident, right. Even not necessarily one where there's injury, but that sets up the conditions that could cause an injury. And the industry worked collaboratively between the pilots, the airframe manufacturers, the engine manufacturers, the regulatory side of FAA, to understand what potentially, what caused this accident, what caused this incident, and how could we work together to prevent it by sharing data. And I think that's a model that we have to look at. Now, I recognize that the industries are very different. 50,000 operations a day versus maybe 150 million operations a day, trained pilots versus the rest of us just driving cars. But it is important that we recognize that data component and that we share the data to make the system safer. But we also have to make sure that we secure the critical infrastructure. We have an office in the Department of Transportation, for example, that works with GPS. And we have to make sure that that critical infrastructure is secure, because it tags a lot of the data that the self-driving cars are going to be using. So there are multiple layers. And from a government perspective, we work with the National Institute of Standards, which established a cybersecurity framework. And across government, by executive order, that is the cybersecurity framework that we focus on and that we look at. But we also work with industry, because we largely are not developing the systems. The auto manufacturers have to put cybersecurity protections into their systems. The airframe manufacturers have to put it into theirs.
Yep. And if I could just add one last thing
to
give back to you.
I want to hear to Jana as well.
Well, just because, just for you all, again, that data, that interoperability, that's not figure out what to give out. I would actually follow what we do, which is our Open Data Act. It's give out everything and figure out what not to give out. Because that enables the research and all the things that need to happen. So you need the very fixed, specific things to make a system work. Absolutely, that's what usually gets into a regulation. But to figure it out, you need an open door to everything so the right community can play in it. Just my thing. And that's what we've done.
And from a technological perspective, I know data is absolutely key. And as we start to collect more data with autonomous systems, whether that's metadata or performance data, what do you see are some of the key things that are needed to help advance the technologies that are so critical, like computer vision and the advancement of AI algorithms to improve performance?
So this is kind of like a moving train, like everything is
Right.
changing so fast. And so I think, being able to have these adaptive systems where, you can never see and learn everything. Like these are not closed systems which you can just sort of package and deploy in the sort of in these everyday settings. So these systems have to have some capability of sort of introspection and adaptation, and this is very difficult. Technologically challenging to do it in the context of these new techniques and models which are sort of coming out. So there are a lot of open research questions in this field. I want to also sort of follow up a little bit on this discussion related to data, that it's not just the data, but it's the entire systems, right, and how they operate. And every company has different sensing modalities, different vehicles, sort of dynamics, models, and so forth. And all these little bits and pieces and how they operate together matter. And so even just to figure out what to share,
Right.
and what are the sort of the critical test scenarios to kind of push the safety and robustness, and then sort of give some feedback to regulators, because I believe in some sense, looking forward, there has to be some common set of tests these vehicles should be able to pass, and yeah.
Great, thank you. Well, and on the vehicle front, I wanted to hear from Ken. We talked about the challenges, but assuming we're able to overcome fear, doubt, and uncertainty, and we have achieved trust, can you tell us what benefits that you see from autonomy moving forward?
Well, sure. I think, and I'm going to repeat some of what Finch said. The overwhelming goal that we have at the Department of Transportation is safety. He mentioned that 37,133 people lost their lives on American roadways in 2017. And unfortunately, that number has been trending up because of economic strength and other issues that raise that number after decades of bringing it down. And so that is our key goal. And one of the things that I've focused on in this job for the last 6.5 years is how to use intelligent transportation systems to bring, to lower the number. How do we use technology to increase safety? So absolutely, bar none, improving the safety and bringing that fatality number, the 6 million collisions, the 3 million with injury, reducing those numbers. And the potential is really there. If we can develop a technology that works better than humans can drive. And let's face it, we all drive fairly well. Probably nobody had a crash coming here today if you drove your vehicle, but there are times when we fail and fail abysmally. Right now we have machines that don't necessarily drive as well as we do most of the time, but if we can get them to the stage where they can drive better than we can, then they will tend not to have those failures unless they're hacked and other issues. And they potentially can drive safer and eliminate that 40% of fatalities that come from impaired driving, medical disabilities, people driving that maybe don't have, that shouldn't be. I was driving this week and saw a silver alert. Obviously somebody had kind of lost their way driving and was lost on the side of the road. If those people could be in self-driving vehicles, in automated vehicles, there's a tremendous benefit. And so that's another group, the underserved, which is an area that we're also focusing on. But I think freight, reducing the cost of freight. Finch talked a little bit about the work we're doing in both long haul and near-term package delivery. And then there's just simply the convenience of how you use your time. It's one of the reasons I use public transportation. I can listen to college courses on tape. I can read a book. There are lots of things I can do that I can't do, but some people actually still do while driving vehicles and should.
Which we don't recommend, right?
We do not recommend that.
Great. No, thank you. Thank you for that. And Jana, I want to hear, you really touched on some of the, challenges as we look across, at the system level, right? So needing to look at the whole system, not just a specific component or part. And data, of course, is a huge input to that, which can, as we talked about, can improve performance. Talk to us a little bit about decision making for autonomous control and where you see that going as it relates to autonomous systems.
I can tell you a little bit, how some of these approaches are being revisited in the presence of these data-driven techniques. So historically, these individual components were always sort of considered by separate group of engineers who kind of came up with their designs, decided on the interfaces, and then the thing was put together. But the interfaces were often extremely brittle, right? And this basically sort of caused a lot of these sort of isolated failures, required very extensive testing. So currently, people are sort of exploring approaches where everything is basically being tested and designed and developed end to end, all the way from the raw sensor data to the higher level decision making. And so then the question is how to do it, what are the type of architectures, how to evaluate, how to sort of achieve very high performance. These are sort of all open research questions. So from the research perspective, this is super exciting because we have this field where the techniques have been developed and used for over 20 or 30, 40 years, but everything is basically being turned upside down with these new techniques, data, computation, and so a lot of the ideas and intuitions which governed the previous strategies are now sort of being revised and sort of incorporated in these sort of data-driven methods where you can just basically look at the entire system as a whole in the context of a particular task.
Great, Jana.
If that makes sense, yeah.
That's why I have,
absolutely,
again, in a safety critical environment, absolutely, that is our struggle, especially around tests and evaluation, right? We like repeatability. We like to be able to do it in test over and over and over and make sure it does it the same every single time. And now that it's a system of systems, that's very hard to do and make repeatable over and over, especially with all of these new inputs, right? That are really wild cards in the system that you want to happen, that have to happen, and that you can't control. How do you do that? How do you test? Like you said, it's being turned over to figure that out. How do you do that, right?
So I think on a positive side, I have to say that the research community and academic community is taking it very seriously. There's a huge amount of effort goes into developing these benchmark algorithms where the ground truth is effectively provided by humans. There's sort of a lot of labeling going on, a lot of simulators. This is the area which is really flourishing right now, and it felt like it was stagnating several years back. And there are more and more realistic, you can carry out repeatable experiments and have these evaluations across the board.
Absolutely, because many of our classical test methods don't work, in autonomy, and really pushing the envelope of research, whether that's virtualized testing or through evolutionary-based algorithms, or whether it's through model-based approaches. Absolutely, we need to continue to push the forefront so that we can make sure that we can test and certify, especially in an FAA environment, that those systems will work and we can trust them. Moving back to Josh, I have one last question, then I promise I'll open it up to the panel the audience for panel questions. But one of the things that really hit me was as you're describing, your work with data, and I know firsthand about the data that you work with and just the sheer amount of it and how critical it is to the air traffic community. Given the state of autonomy today, how do you think data strategies should be adapted in the future?
Well, again, I'll go back to what I said before. There is a question of when to do it, right? So there's data strategy now, and there's data strategy when you're deploying systems that could be two different things. One of the things that I do, Jana mentioned it, is working with the community. So traditionally, we worked a lot with the airlines, I mentioned that, and about a year or so ago, I started this thing called the SWIFT, Swim Industry FA Team. SWIM is how we distribute data. And the goal was really around our Next Gen Advisory Committee to bring in the airlines and again, talk about the next steps, the next 10 years of sharing data, what's needed, how are we gonna do it, what are you doing with it, how do you improve your business with it. What we did as we opened this up was a lot of newcomers came. Google showed up and Uber showed up. I know Finch said don't drop names, but I'm going to. Because we give out data to them and they don't usually call the FAA and ask questions about the data. They just go off and do things. You see like Google Flights that tells you characteristics of flights and how they fly to maybe tell you might want to be on this airline if you care about this, or this airline you care about this. If you're with Uber, you might want to show up at an airport at a certain time when there's the most passengers showing up so that I can be insured to get a ride. The FAA is never going to build that. We give out the data. Again, we built the building block giving out the data, and now the world's doing the stuff with it. But they're showing up to learn more, and these things are all getting intertwined. So back to the data strategy. You got to think big, you have to think interoperable, and you have to think about which phases you're in, what you're really writing a strategy for. Again, I would argue that in this arena, the data we're talking about is for the research and for the development and to enable the innovation, not for the deploying of systems yet. My opinion, I'm definitely not the teacher on this. That said, as we get there, you have to think much more and you have to think all the way, but your strategy has to include how are you securing it, how are you trusting it, how are you authenticating it, how are you using it? Is it used for purpose or not? All of that has to get built into that strategic part of a strategy, I would say, to enable innovation now and a strategy for deploying it later. And the last thing I would leave you with is, again, involve the experts, the community that cares about the result and the community that's building it to deploy.
Great, thank you. We have about 5 minutes left, so I know we have some folks from GovExec who have some microphones. If you have questions for the panel, please feel free to ask.
Okay, so thank you, Bill Buck. I think to Seaview, as a first thing, that's a DOT program where you're tracking marine vehicles and whatnot. The first autonomous marine vehicles popped up on there a couple of weeks ago, so thank you for that. I think to algorithms, and they're just like software, it depends on who's writing them, and so there won't be any basic building blocks for complex problems anytime soon. Complex problems need complex solutions, and so here's the question. What about the Arctic, where we have a lot of other interference going on up there for satellites, very difficult for FM radio communications, AM radio communications? I'm wondering what you're thinking about that. And the reason why I'm thinking about that is because GPS is our system. Galileo is the European system. The Chinese have one, the Russians have one. How do you see those things all coming together in a very important part of the world in the future?
Well, that's a little outside my area of expertise. I am familiar with the ATIS system at Volpe, which tracks about 60,000 vehicles, and it may have certain brand names in certain manifestations of it. So I think that's what you're referring to in Seaview. I really don't know what the coverage is up in the Arctic. We do have an office that deals with GPS issues, and yes, there are, every country is trying to have a GPS capability, and the Arctic is a critical area. I'd have to look into understand a little bit more what any specific issues are. I know at the poles we tend to have some coverage problems with GPS, depending on where some of the satellites are for like down in Australia in the South Pole. I imagine similar issues a little bit up in the North Pole area. So sorry, I don't have a great answer to your question.
Just, I'm not going to answer your question either, but an interesting tidbit on it.
Comment on it.
Just an interesting tidbit on it is that, again, on that spawning innovation, that system that's tracking all of those, I'll just say sea vehicles, was actually built in basis off of what we started with for airplanes. Right. Same concepts, right? Dots moving on a screen, right? That's what I call it. You just got to figure out where it is and how to get that data, and then you can present that. So they were able to move very quickly with that system. I happened to see up at Volpe and learn that piece. Right. So again, that spawning innovation.
Yeah, I don't know, maybe Jana can not answer your question too.
Yeah,
but,
so I mean, I am not familiar with that particular area, but I can sort of pick an orthogonal direction, and for example, in indoors environments, you have a lot of autonomous systems which do not rely on GPS, right? So there are a lot of other mechanisms, and what you will do depends on the task, right? So what is your objective? So a lot of the indoor settings, one cannot rely on GPS.
Yeah.
GPS is unreliable. There are a lot of other sensing technologies which are making headway, integrating, odometry, sort of path integration, gyros, IMUs, what have you. But at sea, I think the challenges are, of order of magnitude more difficult, and I'm not really familiar with them.
Interestingly enough, in air traffic over a decade ago over the oceans, we depended on just someone radioing in their position.
Correct.
And we procedurally put in separation to keep that safe. So you had to be much further apart because, again, it was not trusted data as much. Oftentimes you'd miss a report. It was just either on a longitudinal or latitudinal. But at that same time, again, a very caveman concept. Again, today we have automation to do that, but starting with get the data in so you can do the rest, right? And that was getting the data.
I think we might have time for just one final question.
Hi. I worked in this field early on with ITS American. I was part of the National Architecture bid on the IBM side. And I always thought the National Architecture was such an interesting project. And I was hoping that that mapping per se would go on and have different layers, like a GIS layer, for the regulations and the societal factors that are going to come into play, tort reform and all of that. So I was just wondering, I was reading an article last year from Scientific American, and they predicted that we won't see any of this really on the roads until 2044. Now, it made me wonder what's going on with these societal factors and the legal rulemaking for how we're going to resolve problems between, is it a software error or is it an automotive error? What's happening with that now?
Well, first, thanks for your work on the ITS architecture. We're on, I think, version 8 of the architecture, so it's alive and well. It's gone through a couple reincarnations. We've developed some different tools to enable people to add to the architecture. And in the 3.0 document that Finch mentioned, and he started with the cover of, we actually have a section in 3.0, an appendix, that gets into all the standards work that came out of our architecture. So you can just imagine all the standards that are going to be necessary and how, some of them are very technical, some get into other aspects, data standards versus engineering standards. So that is actually an appendix in 3.0, which is fairly technical for a policy document. So, but that's just to say that all that architecture work is relevant. It's having an influence today. And we also have a number of groups working. You mentioned some of the societal and legal issues. Well, that's why we have a policy group in the area of automation at DOT. I chair an R&D group. Finch chairs a policy group. We actually let the lawyers chair a legal group on autonomy, and we just let the lawyers go so we don't have to hear all the discussions. But then there's also a public affairs. So we really are trying to bring in all the aspects, and this is where I think it's such an exciting time in automation across all of the modes. But this workforce study was about some of the societal aspects, and those are critical issues that have to be addressed, and something that governments have to pay attention to because they don't always have a market slice or an industry representative who's looking at those issues.
Thank you. And thank you, everyone. We will have some time during networking breaks for you to ask additional questions of our panelists, but I want to thank them for spending their morning with us and sharing such rich insights. So thank you.
Thank you.